All right, let's get started. This is Josh. We're going to be working on solving the triangle. So you might have noticed I wrote STT for solving the triangle. All right. So there's two parts to this. It's called solving the triangle, and essentially what you're doing is you're telling the person, or whoever it might be, what are the angles, what are the measurements of the interior angles, and then what are the lengths of all of the sides. Now, can you take some shortcuts? Yes. As you get better at this, figure out what method is going to work best for you. All right. So let's get started, shall we? We shall. I wrote a couple things over here. We're going to be working with sine, cosine, and tangent for this one. These are called trigonometric ratios, which sounds real complicated, right? You're doing trig at this point. You're using some very well-known ratios that allow you to solve for different lengths. And you're able to solve for these lengths based on having some of the angle measurements, okay? Up until now, all we've done is solve these things based on lengths, but now we're actually gonna use some of the angle measurements and then keep on solving. Now, the one thing that you're gonna need is a calculator, because the calculator does a lot of the work for you when it comes to solving these ratios, okay? So we have our right triangle here, and all of this stuff works with right triangles, which is why they kind of teach you the Pythagorean theorem first and the whole stuff about right triangles, and then they go into using it to figure out your angles. So once you've learned the basics of Pythagorean, then they say, okay, well, by the way, you can also use some of these trigonometric ratios. And so what they're talking about with this is, well, let me back up a step. You got to know your parts of the triangle. Okay, you got to know that this right here is the right angle, okay? And we know that the longest length of a triangle is the side opposite the right angle. And so this is the hypotenuse for this triangle. Sometimes it's easy to tell, like it's pretty obvious, like that's the hypotenuse because it looks the longest or the biggest. But sometimes it's hard, and like, you know, even when I draw these in class, my pictures aren't always drawn to scale, so it can be difficult to like really know. But that's going to be your telltale sign, is where the right angle symbol is. All right. And when we're dealing with angles and stuff, or this trigonometric stuff, we just need to remind ourselves there's different labels that we can use. Okay. So when it says we have opposite, adjacent, and hypotenuse. So I don't want to, mess up this triangle because it's kind of nice and it's the first problem we're going to do. If I draw this triangle right here and I draw that little symbol, we know, boom, it's a right triangle. I know how to find the hypotenuse, right? Because it's the side opposite the right angle. And so now I can do some of these labels. So the hypotenuse, which is one of these labels, is the longest side, okay? And then now when it comes to finding things, okay, using these labels, like let's say I was given a measurement in here and I wanted to use one of these. Well, if I'm looking for this measurement here, or if I'm given this measurement here and I'm trying to find this length here, okay, this guy right here, all right, I can use one of these ratios. Adjacent means next to, okay? So this would be the adjacent side. And now you got to kind of start looking at these pieces of the puzzle and say, well, what parts do I have and what parts can I use to then solve this thing? Okay, I know it's kind of wordy and I want to kind of do a couple, and I'm hoping that as you see them, you'll go, okay, I get it. So if I'm given this angle, let's say this is like 37 degrees, okay, whatever. In order to figure out the length of this guy, I can use, let's see here. I know this length over here would be 11, let's say, okay. If I know the measurement of this angle and I know the length over here, then I can plug these into my formula, okay. I'm trying to find the adjacent. I'm given a measurement and I'm given a length, okay? So in order for me to solve this guy, I could say the cosine of 37 degrees is equal to, and then this is when you just fill in your stuff. So we have the adjacent, which would be x question mark, I don't know what it is. And then I have the number 11 over here, which is the hypotenuse, okay? Now, some people might be asking, well, how did you know to use cosine versus sine versus tangent? And like I said, it really comes down to like what information are you given so that you can solve. I was asked to solve for this length here. So if I were to use sine and say sine 37, sine means that I'm going to use the side opposite. So this guy, opposite over hypotenuse. Okay, but if I do sine 37 equals x over 11, I'm solving for this length over here. And I was asked to solve for this length over here. I had to find the adjacent side, not the opposite. And so that's why I chose cosine, because it lets me put an x value in to solve for what I need. Now, if I had used tangent, now I'm dealing with opposite over adjacent. And that doesn't get me anywhere either, because now I'm not even using the number I was given, and I can't use, it's like tangent 37 degrees equals x over y, right? Now you have two variables, and now you're even more stuck. So if this is confusing, just take a second and kind of like let it absorb, all right? But that's the main stuff you need to take away right at the beginning, is just that we have an adjacent side, which is kind of like the side next to the angle that you're given. And you might say, well, how do I know this is the adjacent, not this? Well, because this is the hypotenuse, okay? And so that one we already have, that one is already defined, so therefore this has to be the adjacent. If I had this angle down here and I said, okay, what's the opposite of that guy? The opposite would be this guy up here, because it's opposite that angle. And the adjacent would be this side over here. This is adjacent, this is opposite, this is the hypotenuse. So if I was given the angle over here is like 80 degrees and I said, find the measurement over here, well, I want to find opposite, and I'm given the hypotenuse. So I would use, let's see here, opposite and hypotenuse, I would use sine. So I would say sine 80 degrees equals opposite over hypotenuse. Now, getting into solving it, that's the quick part, okay? We'll get to that in just a little bit. Okay, first I wanted to make sure we all understand like what is opposite, what is adjacent, and what is hypotenuse. Once we have that understanding, then we can start working on the problems, which I think we're ready to do. Okay, so this first one up here is one of the examples in our book. It says to solve the right triangle. Round each side length to the nearest tenth. Okay. So when it says solve the triangle, like I said, they're asking for two things. They're asking for you to figure out the measurements of all the interior angles and the lengths of all the sides. All right. So this book said, well, let's do the angle first. If I know that this guy is 41 degrees and I know this guy is 90 degrees, then I know that plus, another guy, x, equals 180 degrees. Okay. And now I can just solve for x, okay? And there's different ways to do that. You could combine these and subtract them, which is the algebraic way, so I'll do that. I'll just say here 41 plus 90 is 131. So now I have 180 minus 131 is 49, okay? So this measurement here is 40, what did I say, 49? 49 degrees, okay? So now I've solved for all my angles. Now I got to solve for all of these lengths, okay? So I'm just going to stick with the one they gave me. Honestly, it doesn't matter if you use the 41 or the 49 to solve for opposites and hypotenuses and stuff. You're going to get the same approximate answer. Now, just remember, these are all going to be approximate because when you push sine, cosine on your calculator, it's doing some work for you. And so your answers are going to just go on super long with decimals. And that's okay. It just means like they're going to want you to round it. So as long as you do squiggly equals, that's good enough. So let's do, how about we solve for A, okay? Or C, I don't know. We'll do A. Okay, so I know the measurement here is 41 degrees. Okay, and so I have, well, I guess I'm looking for this. I'm looking for the adjacent, right? Because this is the opposite. If I have this measurement here, this is the opposite length. This is the adjacent length. And then this is the hypotenuse. Okay. And so let's see here. I think the book solved for I just kind of want to make sure I'm doing it the way they did it. It looks like they're going to do the opposite over the adjacent, okay, to solve for A first. Okay, so in order for me to solve for opposite adjacent, I'm going to use 41 degrees. So I'm going to say tangent of 41 degrees equals, tangent is equal to, or tan, that number, is equal to opposite over adjacent. Now, can I use A? Yes. Can I use X? Yes. It really doesn't matter what you use. All right. Now, this is where you need your calculator, okay, because we're going to figure out what A is equal to. Different methods, right? If you have a whole number and then a fraction, you could multiply both sides by A and then divide, or whatever you want to do. It's really up to you, okay? So we have 41. So on our calculator, I have sine, cosine, tangent buttons. So you just push tan 41 equals, and I get 0.869, and then I have 6 over A. All right. And now I need to solve for A. And so there's different ways to do this. I think the book just has you, let's see here, they just have you move everything around, okay? So they have you multiply both sides by A, so that the A's cancel, and now you have A times that, and then you divide both sides by 0.869, divide by 0.869, so A equals 6 over 0.869. So let's see here, 6 divided by 0.869, which is 6.9, approximately. Okay, so you might have done this part differently. I wanted to just show you that's usually the quickest method. You got to get rid of, you can't just divide both sides by 6 because you still have something divided by A. So your answer is not A, okay? Which is why I felt I was more comfortable to just multiply both sides by A, get the A out from underneath the fraction sign, then divide both sides by the 0.869, and then keep going. And once I got to here, we read our fractions down, and I just put it in the calculator and get my answer. Now, this is where you can kind of cut some corners. So if I know that this over here is 6.9, there's two ways for you to solve for C. The first method is, well, it's a right triangle. You have this length, and you're looking for this length. So could you do A squared plus B squared equals C squared? And then solve for C using the Pythagorean theorem? Yes. Could you also use these trigonometric ratios? Yes. So I personally am okay with either one. Because the lesson is on solving the triangle and they're really pushing you to learn sine, cosine, tangent, I say it's a little bit better to kind of use it just to practice. But in the end, you're going to, if you're like taking a test and you're rushing through this, like whichever method is going to be faster for you, I say use that. But since we're learning it, we'll take a couple minutes here. So now I want to solve for the next guy here. And so then let's see here. It looks like the book wanted to use sine 41. So I'm going to kind of use some space over here. So they used sine because they can do sine 41. So I have sine 41 degrees equals the opposite, which is 6, over the hypotenuse, which is C. All right. Now, once again, if I want to, I can plug this into the calculator and solve for the decimal first. I could multiply both sides by C's. Sorry, I did a dot there and a times there. I can multiply both sides by C's so that I cancel that guy. So now I have C times sine 41 degrees equals 6. It doesn't matter if you do the decimal first or if you just write it out, whatever. And now I got to divide both sides by sine 41 degrees divided by sine 41 degrees, okay? So now again, I have this information. Depending on your calculator, some calculators will let you put all this in, depending on like how it works and everything. So I have 6 divided by, and then I push sine 41, and I get, oh yeah, it's another decimal, like 9.1, okay? So I know that this length here is 9.1. Now, like I said, if you were to just go a squared plus b squared equals c squared and solve for it, you'd get the same approximate answer, right? About 9.1. And that would be perfect, okay? So you might notice I didn't even use the 49, but that's okay. They just want you to do this by solving. They want to make sure, do you understand how to get the angles and how to get the lengths, okay? So I could have done, let's see here, I could have solved for A by doing sine 49. Let's see here. I don't know the hypotenuse, so I can't. I could do cosine 49, because that would be cosine 49 equals adjacent over hypotenuse, and I could solve for this guy first. I could do tangent, which would be tangent 49 equals opposite A over adjacent, which is 6, okay? And then I could solve it as well. And so if you want, play with that. See if you can get the answer using this angle or this angle. And if you can, you got this down, all right? I know there's a lot going on, but that's okay. Like, we're just going to take our time with these. You know, most of the nice thing is most of this is done by the calculator for you, so you really don't have that much you need to do. It's more about understanding what labels go where. How do I know which one is the adjacent? How do I know where the opposite is and all that kind of stuff? All right, so let me erase all this. And as I'm writing out the next problem, you may have heard from parents, friends, whatever, there's all these nicknames to remind you, like, how do I know what goes where? And for this one here, you might notice that the sine equals the opposite over the hypotenuse. And so some people will say that one is called SOH, or S-O-H. And then we got the next guy here. Cosine is equal to adjacent over hypotenuse, which is CAH, C-A-H. And then we have tangent, which is tangent over equals opposite over adjacent. So we have TOA. So when it comes to reminding yourself or memorizing these, for some people it's really easy to just remember, oh yeah, so TOA. And that reminds you like what goes where, right? So is sine is equal to opposite over hypotenuse, adjacent over hypotenuse, opposite over adjacent, okay? So if you want, just say SOHCAHTOA, and that will remind you like what goes where when you're solving these guys. All right, let's see here. Let's do that next exam. Let's do another problem here. This one I want to draw it kind of like that. Now the triangles might be turned upside down, whatever, right? You're mainly looking for some key parts. You're looking for that symbol right there, which tells you that it's a 90 degree. Is this guy a 90 degree? Oh, it is, but the 90 degrees in the wrong spot. So let me actually, you know what? Let me redraw this one because they actually had it like that. Gosh, that's bad. I guess this is the problem with doing this in one take, right? One take, one cut, make mistakes, just keep on rolling. Okay, and then we have some lengths here. This is 7, 25, 24, and it says find the values of the 3 trigonometric ratios for angle A. And we have A, B, and C. So I'm going to write those guys real big. Okay, so we know this is angle A, okay? And all they want you to do is exactly what they asked. Write out the trigonometric ratios. They don't want you to solve. They don't want you to do anything extra just yet. They just want you to label these so you get better at knowing, like, where's the hypotenuse? Where's the adjacent? Where's everything, right? And now we know, because of the right angle symbol, we know this guy is the hypotenuse. And, you know, as you're doing this when you're first starting, if you want to label it, if that makes it easier for you, then you can, just because you know that that's the hypotenuse and it's easy to fill all these in. You know, if that works for you, then do it. Okay, so they want you to go through the sine, cosine, and tangent of the angle A. So we would have the sine A. If you want to put the degree sign, you can. I don't think the book does. Sine A is equal to what? Well, sine is equal to opposite over hypotenuse. So if this is the measurement, or this is the angle that I'm using, what would be the opposite? 24. And what would be the hypotenuse? 25. Okay? That's all they want you to do. And I hope you're saying, oh my gosh, that's easy. Okay, let's move on to cosine. So the cosine of A is equal to adjacent over hypotenuse. So adjacent, right? This is the opposite because it's like opposite that angle. So the adjacent is a 7, and then the hypotenuse is a 25. Okay? And now we have the tangent of A, which is, let's see here, tangent is opposite over adjacent. So opposite over adjacent. Okay? And that's it. I don't know, circle your answer and you're done. Okay? Hopefully those ones you're like, oh dude, that's not even bad. Okay? But again, they're getting you to understand where's the adjacent, where's the opposite, where's the hypotenuse, where's the right angle, like how does all of this stuff come into play? And of course they're going to start turning the triangle so it's this way, upside down and all that. But don't flip out, just take your time and just label them, okay? I like to label hypotenuse sometimes just because it knocks one thing out for me and then I understand, okay, this goes there, this goes here, and all that kind of stuff. Okay, the last thing I want to cover, actually I think there might be two things, but we'll see. Sometimes on the homework it just says, let's see here, solve, use a calculator to find the value of these trigonometric ratios. And like they just said sine 37 degrees. Sine 37 degrees, okay? If they just give you this and they're like, just come up with a decimal value or a number value, you just take that and you put it in your calculator. So your calculator should have sine, cosine, tangent. Let me clear that. Sine 37. It does put a parentheses there, but you don't need to put a second one if you don't want to. You can just push equals. And then they're usually decimal answers. So you could say about 0.6. You could do 0.6. If you want to round it a little bit, that's fine. Again, I'm looking for big picture, main concepts. I'm not looking for like, what number is the 6th digit after the decimal, okay? All right, so that's how you just solve for that. And then they give you some more problems where they say solve and round each side length to the nearest whatever, okay? So let's see here. I got a triangle, X, Y, Z. That length is 7. Let me draw this guy up on the board. We'll do one more together, and if you can do this guy, then you are rocking and a-rolling. All right, they gave me that length there. They labeled this triangle X, Y, Z, and then they said this one was 39 degrees. Okay, so that's all the information you're given. If at this point you want to solve the triangle on your own and then pause it, solve it on your own, and then come back and see what I did, awesome, okay? That's exactly how you're gonna learn this. If you wanna follow along, that's okay, but I don't think that you'll take away as much. But, who knows? All right, let's get started, shall we? We shall. We have 3 different angles. They did say to solve the triangle, right? So I gotta get all my interior angles, then I gotta get my lengths. And so I might as well do the interior angles first. I know one of them is 90. Oh, that marker's gone. I know this guy is 90. I know this guy is 39. I know I got one more. I'll just say X. And I know it all equals 180. So let me just combine and subtract. So 90 plus 39 is 129. So 180 minus 90 plus 39, 129 is 51. So I know this guy here is 51 degrees, okay? Now I need to solve for all my sides, okay? I need to know all of these measures. And so, let's see here. I need to know these lengths, I should say. I can use either of these 2 angles to solve for the rest of this stuff. Since I found this angle, why don't we use that and then see what we can get? Okay, so if I have this measurement and I have the hypotenuse, right? The hypotenuse, okay? Then what would be the easiest thing to use? Well, if I have this measurement and I'm trying to find this guy, and so I can do opposite over hypotenuse. Is there a formula that has opposite over hypotenuse? Yes, it looks like sine, okay? So I'm going to do sine 50 degrees equals opposite over hypotenuse. And now I'm just solving for x. Let's see here. X is on the top, which is kind of interesting. So for this one, it's actually kind of quick, or I don't know, seems quicker for me. Sine 50 is 0.766. All right, and now if I just want to solve this for x, I can just times both sides by 7 to get rid of that guy. So I have that number 0.766 times 7 is about 5.362, about 5.3, whatever, okay? So we can say this side over here is 5.3. You want to round it 5.4, that's fine, whatever. Okay, and now I got to get this guy over here. So do I have something that I have in measurement, and do I have a formula that would help me solve it using the adjacent side and the hypotenuse? Now you might be asking, well, Josh, couldn't I just do, again, Pythagorean theorem, a squared plus b squared equals c squared, and then just solve it that way? Yes. Will you get the same answer? Yes. But I want to just practice my trigonometric ratios and see what I get. So I can do the adjacent over the hypotenuse to solve for that guy. So I can do, is there a formula for that? Adjacent hypotenuse. Let's see here. Adjacent and hypotenuse, it looks like cosine. Cosine 51 degrees is equal to x over 7. All right, now let's push cosine 51 and get 0.629 equals x over 7. And let's multiply both sides by 7. Isolate the variable. So now we have 7 times 0.629 is about 4.4. All right, so this length over here is about 4.4. Okay, all right. So that should get you started on all these ratios. Again, practice, all right? It is kind of weird because you're like, how do I know which one is the adjacent? How do I know which one is the opposite, right? And so if we have this measurement here, I know the opposite is the opposite side from the angle. The adjacent is the one that's adjacent to it. It's touching the measurement, if that helps. And the hypotenuse is always the one opposite the right angle symbol, all right? Okay, let's get started on some work. Take your time with these. Email me questions. Let me know how I can support your day.